Hi, this is Mrs. LaBarbera. This is Regents Physics Wave Basics. So today I want to talk about phase of a wave. So what does phase mean? Phase usually is the points on the wave. It's the position of the points on the wave. Usually it is expressed in degrees or radians. So for example, we're given this wave. We have points A, B, C, D, and E. How do we determine the phase of each point? So to determine the phase, we have to go back to math. When you learned, trig in the functions, this is a sine function. So we know sine 0 equals 0, sine 90 degrees. You have positive 1, that's a maximum point. Next 0 is 180 degrees. And after that, 270, you have sine 270 give you negative 1. That is a maximum negative. Then you keep going, you will have 0 again at 360 degrees. So this completes one cycle. So we said the length of one cycle is called wavelength, and the time of one cycle is called period. So in this case, I draw these lines to indicate each interval between the line that's a quarter of a cycle. So 4 quarters consists of one wave. Now, how do we describe the phase of each point? We use degrees, or we can use radian. So again, at B is 90 degrees or pi over 2, C 450 degrees or 5 pi over 2, and so forth. In-phase points. So in-phase points on periodic wave are moving in the same direction, having the same displacement. Or they can be the same displacement, not both up or both down. That means they could be both have 0 displacement also. So one way to figure it out is you look at the points. Are they 1 wavelength apart, or 2 wavelength apart, or 3 wavelength apart, and so forth. So in-phase points has to be the whole number of multiple waves. In this case, which points are in phase? So in-phase points are usually have 4 90s, so they are 360 apart. B and C are in phase. Another 2 in-phase point is A and E. They are 2 wavelengths apart. So from A to here, that's 1 wave. Then here is another wave. So A and E are in-phase points. So is B and C. Another way to look at it is B and C have the same displacement. They have both positive maximum. They are also moving in the same direction. Same as A and E have the same displacement and moving in the same direction. Out of phase. So out of phase in regions really means they are 180 degrees apart. Usually points out of phase are half a wavelength, 1.5 or 2.5, and so forth. So another characteristics of out of phase point is they are moving in the opposite direction and having opposite displacement, or have the same displacement, but they have to move in the opposite direction, either opposite displacement or same displacement. For example, in this same wave, which points are out of phase? So out of phase in this case is C and D. Those are the points are half a wavelength apart. So C and D. One is up, one is down, one is moving downward, the other one is moving upward. So they are totally opposite. Let's take a look, couple of examples. So which points on the wave diagram below are 90 degrees out of phase with each other? So again, if you still are not sure, you can draw the vertical lines. So each vertical line is 90 degrees. So in this example, is D and E are 90 degrees apart. So is A and B are 90 degrees apart. Which 2 points are 180 degrees? 180 degrees is half a wavelength. So in this case, there are only 2 points that's half a wavelength apart, which is X and Y. These are out of phase. They have exactly half a wavelength apart. X has maximum negative, Y has positive maximum. And if the wave is going to the right, Y would be moving downward, X would be moving upward. So the points that are 180 degrees apart are X and Y. Another example. So this diagram shows a periodic wave which 2 points on the wave are again 180 degrees out of phase. So out of phase means they are half a wavelength apart. We know A and C are half. C and E are half. E and G are half. G and I also half a wave. Besides those, we know B and D are half. D and F is half. F and H is half. So those are the points that's 180 degrees apart. Again, if you still having trouble, draw the lines. When you draw the lines, you know each line, each interval between the line is 90 degrees. You can just count it. So these are the points that's 180 degrees out of phase. There are many, many points. Another example, again, which 2 points are 180 degrees out of phase. 180 degrees out of phase is half a wave. So A and B, so here is a cycle. A to C is one cycle. A to B is half a cycle. B to C is another half. C to D, D to E, E to F, F to G, and G to H. All those points are half a wavelength. So they are 180 degrees out of phase. Another example. So which point on the wave diagram is in phase with point B? So in phase means you must have the same displacement. So there are other 3 points have the same displacement. A is the same as B, so it's D and E. So besides the same displacement, you have to move in the same direction. A is moving downward. So one way to determine which way you're moving is you look behind it, because the wave is going to the right, so to the left is behind it. To the left is lower than A, that's what A is going to do next. So A is going to move downward. On the other hand, B, you look behind B. Behind B is higher than B, so that's where B is going to go. B is going to move upward. So again, you look behind D, those are lower than D, so that's what D is going to do. D is moving downward. On the other hand, E is moving upward. So B and E are in phase. And some people probably say, well, that's easy, just corresponding points on the wave. So again, B and E are corresponding points. They are corresponding to the length of one wave. So E has the same phase as B. That's it. Thanks for watching. See you next time.